Okay, so we're 2.3 inverse trig functions. You can read down through some of these properties here of inverses, but we're really going to get into the nuts and bolts of it. Take a look at graphs and so forth. Some of these things here should be a little bit of review of geometry. Okay, as in geometry class, when you knew two sides of a triangle, you were able to use the inverse of sine or cosine to determine the angle that was missing. So first of all, you need to understand that a function will have an inverse if the function is 1 to 1. Okay, functions are 1 to 1 if they have one x value for every one y value. It basically means that they pass the vertical line test and the horizontal line test. Okay, if we're evaluating the inverse of a function at x, then it's going to equal x, and the same thing is true here if it's evaluating the function of the inverse. Okay, and basically what that means is like when you did inverses in algebra 2, if you plug 2 into an equation for x and you got 3 for your answer, you should better plug 3 into the equation for y and get 2 as your answer. So the domain of f is equal to the range of the inverse. So in algebra 2, when you were finding inverses, you talked about switching x and y, the switch and solve method. This is what we're talking about here as well. All right, which also means that the range of the function, okay, is equal to the domain of the inverse. All right, the graph of f and the graph of the inverse are symmetric with respect to the line y equals x. Okay, and if a function y equals f of x has an inverse, the equation for the inverse is going to be x equals f of y. Again, the switch and solve method from algebra 2. All right, so let's take a look at what some of these inverses actually look like. Okay, first let's look at sine. Okay, for graphing our normal sine curve, all right, then it would look something like let's change this around a little bit here. Let's make that our y-axis. Okay. If we're graphing our normal sine curve, right, it's going to go something like this. Okay. And our 5-point method, right? So that's sine. Now remember, we're reflecting that across the line y equals x to get the inverse function. So that will be somewhere like this line right here. Okay, so basically our sine function is going to revolve around the y-axis instead of the x-axis. Okay, but let's talk about some of these pieces here. Is the function 1 to 1? No, right? Because it does not pass the horizontal line test, which means we have to restrict the domain for sine. We're not going to be able to graph the whole curve, or else our inverse would not be a function. So let's first just take a look at what that inverse would look like. Okay, it would look something more like this. Okay, so we can already see that that's not going to pass the vertical line test. All right, which means that it would not be a function. So what do we do to get it to pass the vertical line test is we're going to restrict, all right, the domain to just this region. All right, so if I just zoom in on this region and I only focus on this, okay, that would be my inverse graph of sine. All right, so again, I'm ignoring this piece and this piece. Okay. Now, what I have here will pass the vertical line test. All right, and again, if I think about what those values were, you flip-flop your domain and range. That means this is 1, and this is -1. Okay, that means that this is pi over 2, and this is negative pi over 2. All right. Okay. So the range for y equals sine that we want to use to make it 1 to 1 is going to be -1 to 1. All right, the domain value they give us a range value of -1 is going to be negative pi over 2. That's on your unit circle. Positive pi over 2 for 1. So in summary, if we're trying to graph the inverse of sine of f(x), we're only doing it from -1 to 1 for our x values and negative pi over 2 to pi over 2 for our y values. All right. So basically, what's going to happen here is when you type these into your calculator, if you were typing in the inverse sine of any ratio, you're always going to get an answer in your calculator between -90 and 90. And then we just need you to realize that there could be more answers than just that one because of the restricted domain. The calculator is going to give you the answers that are in that restricted area and will not give you other answers around the unit circle, even though we know sine would have the same values elsewhere around the unit circle. So let's think about an obvious one here, sine of negative a half. Okay, you already know that that happens two places. That happens at 11 pi over 6, and that also happens at 7 pi over 6. Okay, however, if you type that in your calculator, it's only going to give you one of those two answers. You then have to know where that other answer will occur. So that's basically the gist of the day here. So same idea for cosine. Not a lot changes with this, so we'll just buzz this pretty quick. All right, again, my cosine curve would look something like this. All right, and it goes this way as well to the negatives. Okay, and it is also not 1-to-1, of course, because it doesn't pass the horizontal line test. So if we're restricting the domain for cosine, same idea, or the the range, will be negative 1-to-1. All right, what domain value will give you a result of negative 1? That's going to be pi, and positive 1 will be 0. Remember, because cosine now is the x values, not the y values at those places. Okay, so if we restrict the domain for cosine, that curve is going to look very similar to one we just talked about. Okay, so it would look something like this instead. Zoom in here. Okay. Oops, I have that. Sorry about that. That looks like the reflection of sine. All right, and again, we're looking at pi, okay, and 0. All right, and again, it's going to go negative 1-to-1. All right, so in summary, where the function of cosine is going to be true between negative 1 and 1 for x, which is going to end up being between 0 and pi for y. And again, same idea, when you're trying to solve a triangle, your calculator is going to give you one answer. So we know that cosine is negative a half at two different places. Right, cosine will be negative a half at pi over 3. It will also be negative a half at 4 pi over 3. Got that wrong here. All right, 2 pi over 3 and 4 pi over 3. But when you type in your calculator, it's only going to give you one of those answers. It's only going to give you this answer here. So you have to know that there's also another possibility. And that's really the basics of what we're talking about there. We're going to focus mostly on the solving triangles piece, okay, with using inverse. But we also wanted to at least know what the graphs and the restricted domains look like.